Hermann Göring laughed when he heard the numbers. 50,000 aircraft per year from a nation that could barely produce 3,000. The Reichsmarshal of Germany's mighty Luftwaffe dismissed it as American propaganda, a fantasy from a country that, in his words, knew only how to make refrigerators and razor blades. But the figure announced by President Franklin Roosevelt in May 1940 was not propaganda. It was a promise. And by the time the war ended, America would not build 50,000 planes in a single year. It would build nearly 100,000. Göring's laughter would echo through history not as mockery of American weakness, but as testament to his catastrophic miscalculation. Before we go deeper into how this decision changed the Pacific War forever, make sure to subscribe for more history that actually happened. The spring of 1940 marks a moment when the world stood at the edge of catastrophe. Nazi Germany's war machine carved through Europe with mechanical precision. Poland fell in weeks. Denmark surrendered in hours. Norway resisted but collapsed. Then came May 10th, when German forces crossed into France, Belgium, and the Netherlands simultaneously. The blitzkrieg tactic proved unstoppable. Panzer divisions moved faster than armies could retreat. Luftwaffe bombers struck cities before air raid sirens finished their wails. By June 14th, German soldiers marched beneath the Arc de Triomphe. France, the nation that held the line for 4 years in the previous war, surrendered in 6 weeks. Britain stood alone. Prime Minister Winston Churchill spoke of fighting on beaches and landing grounds. But words would not stop Messerschmitt fighters or Junkers bombers. The Royal Air Force possessed fewer than 700 serviceable fighters. Across the English Channel, Hermann Göring commanded over 1,300 combat aircraft specifically designated for the assault on Britain. German fighter production ran at approximately 300 aircraft per month. British factories managed similar output, but attrition was already bleeding Fire Command dry. Every pilot killed took months to replace. Every Hurricane or Spitfire destroyed represented irreplaceable aluminum and skilled labor. The mathematics of survival looked grim across the Atlantic Ocean. President Franklin Roosevelt watched Europe burn and understood that geography alone would not protect the United States. The Atlantic was wide, but not infinite. If Britain fell, if the Royal Navy surrendered or scuttled itself, nothing would stand between America and German U-boats operating from captured British ports. Japan's expansion in Asia threatened American interests in the Pacific. War approached not as possibility, but as inevitability. Yet the United States possessed an army smaller than Romania's, a navy stretched thin across 2 oceans, and an air force that existed primarily on organizational charts rather than airfields. American aircraft production in 1939 totaled 2,141 military planes. Germany produced 8,295. Japan manufactured 4,467. The Soviet Union built 10,382 in raw production capacity. The United States ranked behind nations it would eventually be forced to fight. American aviation companies remained small operations scattered across the country. Boeing employed fewer than 4,000 workers. Consolidated Aircraft, which would later become famous for the B-24 Liberator bomber, functioned out of a single facility in San Diego. North American Aviation occupied a modest plant in California. These companies produced aircraft in dozens per month, not hundreds. Mass production techniques that had revolutionized automobile manufacturing had never been applied to aviation. Aircraft construction remained fundamentally artisanal. Each plane was built by hand, fitted by eye, riveted by craftsmen who viewed themselves as specialized, laborers rather than assembly line workers. But Roosevelt saw something others did not. He recognized that war would be decided not by the courage of individual soldiers, but by the volume of material societies could generate and sustain. Modern warfare consumed resources at rates that exceeded traditional military thinking. A single armored division required thousands of tons of fuel, ammunition, spare parts, and replacement vehicles monthly. A bomber formation needed constant replenishment of aircraft to maintain operational strength. Infantry divisions burned through small arms ammunition faster than peacetime factories could produce it. The nation that could mobilize industrial capacity fastest and most completely would win. Everything else was commentary. On May 16, 1940, Roosevelt addressed a joint session of Congress. His message contained no rhetoric about democracy or freedom. It contained numbers. He requested authorization to expand military aircraft production to 50,000 planes per year. Not 50,000 planes total. 50,000 planes annually. The figure represented an increase of 25 times current production rates. It demanded factories that did not exist, workers who had never seen an aircraft, raw materials that had not been mined, and organizational systems that had never been tested. Congressional members sat in stunned silence. Military planners considered the goal impossible. Aviation industry executives quietly calculated that meeting such quotas would require every existing aircraft factory to multiply its output by factors of 10 or more. Some considered it fantasy. Others called it desperation. None believed it achievable. In Berlin, intelligence reports delivered Roosevelt's speech to Hermann Göring's desk within hours. The Reichsmarshal read the translation and laughed. He summoned his staff and read the passage aloud, pausing for theatrical effect when he reached the 50,000 figure. Americans, he declared, know nothing of war production. He had commanded fighter squadrons in the previous war, earning the Pour le Mérite, Germany's highest military honor. He had built the Luftwaffe from nothing into Europe's most powerful air force. He understood aircraft production intimately. 50,000 planes per year required not just factories, but an entire industrial ecosystem of aluminum refineries, engine manufacturers, instrumentation suppliers, and specialized machine tool producers. It required trained workers by the tens of thousands. It required organizational expertise that took years to develop. America possessed none of these prerequisites. The statement was propaganda, designed to intimidate Germany and reassure Britain. Göring filed the intelligence report and forgot about it. He had an invasion to plan, but while Göring laughed, American industry began to mobilize. In May 1940, William Knudsen resigned as president of General Motors, the largest industrial corporation in human history. He took a government position paying $1 per year. Roosevelt appointed him director of the National Defense Advisory Commission with a simple mandate: convert American industry to war production. Knudsen was 61 years old, a Danish immigrant who had risen from machine shop floor sweeper to corporate leadership through sheer competence. He understood manufacturing at levels most executives never reached. He knew how metal flowed through stamping dies, how assembly line choreography reduced production time, how inventory management prevented bottlenecks. Under his leadership at General Motors, the company had produced more automobiles than any organization in history. Now Roosevelt asked him to perform an even more remarkable feat: teach America how to build weapons. Knudsen approached the problem methodically. He recognized that aircraft production could not simply be ordered into existence. Factories needed retooling. Workers required training. Supply chains had to be established. He began traveling between Detroit, Washington, and aircraft plants on the coasts, spending 18-hour days studying production bottlenecks. What he discovered disturbed him. American aircraft companies operated more like craft guilds than modern manufacturers. Workers fabricated parts to individual specifications. Engineers made design changes during production runs without considering downstream effects. Quality control consisted of visual inspection by experienced foremen. Nothing was standardized. Nothing was interchangeable. Building 50,000 aircraft per year under such conditions was not merely difficult. It was impossible. The solution lay in automobile manufacturing principles. Henry Ford had pioneered assembly line production 3 decades earlier, revolutionizing how goods were made. The concept was simple: break complex assembly into simple repetitive tasks. Move the work to the worker rather than the worker to the work. And standardize every component so parts from different suppliers fit without modification. Applied to automobiles. These principles had reduced the time required to build a Model T from 12 hours to 93 minutes. Applied to aircraft, they could multiply production by factors previously considered impossible. But aircraft were not automobiles. They were larger, more complex, built from different materials, and subject to tolerances measured in thousands of inches rather than fractions. Whether assembly line techniques could translate to aviation remained an open question. That question would be answered at Willow Run. In January 1941, the Ford Motor Company broke ground on the largest factory building ever constructed. Located in rural Michigan farmland 25 miles from Detroit, the facility would stretch over 1 mile long and a quarter-mile wide, covering 3.5 million square feet under a single roof. Its sole purpose was to build B-24 Liberator bombers using automobile assembly techniques. The B-24 represented one of America's most advanced heavy bombers. A 4-engine aircraft, designed by Consolidated Aircraft in San Diego. It weighed 65,000 pounds fully loaded, contained 488,193 individual parts, and required 30,000 separate components assembled into 24 major subassemblies. Consolidated built them at a rate of 18 per month. Ford proposed to build 1 per hour. The proposal seemed insane. Charles Sorensen, Ford's production chief, had visited Consolidated's San Diego plant in early 1941 to study B-24 construction. What he witnessed appalled him. Bombers sat in fixed positions while workers moved between aircraft carrying tools and parts. Each plane required 3 months from first rivet to final inspection. Skilled workers fabricated components individually. Design changes occurred mid-production. Sorensen sketched ideas in his notebook and flew back to Detroit, convinced that everything Consolidated did was wrong. "They're building them like craftsmen build furniture," he told Henry Ford. "We can build them like we build cars." Ford gave him authorization to proceed. Willow Run would not just be a factory. It would be an experiment in whether industrial mass production could be weaponized. The B-24 itself posed unique engineering challenges that made Ford's ambitions seem even more impossible. Consolidated Aircraft had designed the bomber around the Davis wing, a revolutionary high-aspect ratio airfoil developed by aeronautical engineer David R. Davis. The wing's narrow chord and long span generated exceptional lift-to-drag ratios, allowing the B-24 to fly faster and farther than any comparable bomber. The wingspan stretched 110 feet, 7 feet longer than the B-17 Flying Fortress. Yet the wing area was smaller, producing a wing loading that demanded precise manufacturing tolerances. Each wing contained self-sealing fuel tanks holding 2,814 gallons of high-octane aviation gasoline, enough to fly missions exceeding 2,000 miles. The wing structure itself was a marvel of stress-skin aluminum design, using no external bracing yet capable of supporting the aircraft's maximum takeoff. Weight of 65,000 pounds. Power came from 4 Pratt and Whitney R-183O twin Wasp radial engines, each producing 1,200 horsepower at takeoff. These engines represented another production miracle within the larger miracle of aircraft manufacturing. The Twin Wasp was a 14-cylinder 2-row radial that had entered service in 1932. By 1945, Pratt & Whitney and its licensees would build, 173,618 R1830 engines, more than any other large aircraft power plant in history. Each engine weighed 1,468 pounds, contained 1,464 individual parts, and required machining tolerances measured in thousandths of an inch. The engines alone demanded a supply chain involving hundreds of subcontractors producing cylinders, crankshafts, magnetos, carburetors, and reduction gears. Every component had to meet exact specifications because aircraft engines operated under conditions that destroyed automotive engines in minutes. Continuous high-power output, extreme temperature variations from ground level to 25,000 feet, and reliability requirements that accepted zero tolerance for failure. The scale of the undertaking became clear as construction progressed. Willow Run would require 12,600 tons of structural steel, 90 acres of concrete flooring, and 14 miles of overhead conveyor systems. The building consumed materials equivalent to constructing a small city. Electrical wiring stretched 265 miles through walls and ceilings. The heating system required 7,500 tons of coal monthly during Michigan winters. Water consumption reached 660,000 gallons daily for manufacturing processes, cooling systems, and worker facilities. Rail sidings penetrated directly into the factory, allowing boxcars loaded with aluminum sheet, engine components, and electronic instruments to unload inside the building. Ford's purchasing department placed orders for 15,000 machine tools, many of which had to be custom designed because no existing equipment could handle the precision work required for aircraft components. Construction began before complete blueprints existed. Steel girders rose from Michigan farmland while engineers still argued over production sequences. Ford's purchasing department ordered machine tools worth $20 million before the building had walls. The gamble was enormous. If the concept failed, Ford would have wasted resources that could have built thousands of conventional aircraft. If it succeeded, America would possess a weapon Germany could not counter, industrial capacity that exceeded military requirements. By September 1942, the first B-24 rolled off Willow Run's assembly line. It had taken 18 months from groundbreaking to first aircraft. The bomber was beautiful, silver aluminum gleaming under factory lights. 4 Pratt & Whitney radial engines mounted on high aspect ratio wings. Gun turrets positioned nose, tail, and waist. It was also incomplete. Major components did not fit properly. Instruments malfunctioned. The landing gear failed quality checks. Ford workers had followed blueprints precisely, but the blueprints themselves contained errors that Consolidated's experienced craftsmen normally caught and corrected during assembly. At Willow Run, such corrections were impossible. The assembly line moved whether parts fit or not. Production crawled. In the first month, Willow Run completed 1 aircraft. In the second month, 2. By December 1942, total output reached 18 bombers, matching Consolidated's monthly production, but falling catastrophically short of Ford's projections. The fundamental problem lay in the collision between automotive mass production principles and aircraft manufacturing realities. Ford's system depended on standardization so absolute that any part from any supplier could install in any vehicle without fitting or adjustment. Automobile tolerances measured in hundreds of inches. Aircraft tolerances measured in thousandths. An automobile door that did not fit perfectly might rattle but still functioned. An aircraft wing that did not fit perfectly would tear off at cruising speed, killing the crew and destroying the machine. Ford workers, trained to build cars where close enough was acceptable, struggled to internalize aircraft precision requirements. Rejected parts piled up in quality control areas. Rework consumed time that assembly line scheduling could not accommodate. The entire system threatened to collapse under the weight of its own ambitions. Critics attacked the project mercilessly. Senator Harry Truman visited Willow Run in February 1943 and declared it a monument to inefficiency. Newspapers began calling it Willow Run, Will It Run? The criticism stung because it contained truth. The plant employed 42,000 workers, but produced fewer aircraft than Consolidated managed with 8,000. Something was fundamentally wrong. The problem lay not in the concept, but in the execution. Assembly line production demanded absolute standardization. Every part had to be identical. Every dimension had to meet specification. Every supplier had to deliver components that fit without modification. But Consolidated kept changing B-24 designs based on combat feedback from Europe. Each change rippled through Willow Run's supply chain, requiring new tools, new jigs, new training procedures. Parts manufactured in January did not fit assemblies produced in March. Inventory piled up. Partially completed bombers sat on the assembly line waiting for corrected components. Workers stood idle. The entire system ground slower and slower until it nearly stopped. Charles Sorensen made a decision that defined the project's success. In April 1943, he announced that Willow Run would no longer accept design changes from Consolidated. The B-24 specification was frozen. Any modifications required to incorporate combat improvements would be implemented as block changes affecting hundreds of aircraft simultaneously, not as individual alterations. Consolidated's engineers protested. The military protested. Sorensen was inflexible. "You can have 100 planes next month with last year's design," he told them. "Or you can have 20 planes next year with next month's design. Choose." The military chose volume. Training became as critical as tooling. Ford established schools within the plant where experienced aircraft workers taught automotive workers the difference between building cars and building bombers. Riveting techniques that worked for automobile bodies failed on aircraft aluminum, which was thinner, harder, and less forgiving. Workers learned that rivet guns had to be positioned at exact angles, that pressure had to be calibrated precisely. That visual inspection was insufficient, and only gauge measurements verified quality. The learning curve was steep and painful. It took months before Ford workers achieved the proficiency that Consolidated's experienced craftsmen demonstrated naturally. Within 3 months, Willow Run's production rate tripled. By August 1943, the plant completed 100 bombers per month. By October, 200. The assembly line that had seemed like failure in 1942 became the model for all future aircraft production. Workers no longer fabricated parts individually. They performed single tasks repeatedly, drilling rivet holes, installing hydraulic lines, mounting engines, testing electrical systems. Each station took minutes to complete. The bombers moved continuously through the factory on an overhead conveyor system, advancing 36 inches every hour. What had once taken 3 months now took 24 hours from first component to completed. Aircraft. April 1944 marked Willow Run's peak production. 428 B-24 Liberators completed in 30 days. 1 bomber every 90 minutes. Day and night, month after month. The plant never stopped. 3 shifts of workers rotated through 24 hours daily. Aluminum arrived by rail car was stamped into fuselage sections, assembled into subcomponents, integrated into complete airframes, fitted with engines and instruments, fueled, armed, and flown away by military pilots who collected them directly from the factory runway. The entire process from raw material to operational bomber required less than 1 week. Nothing in industrial history compared. No factory anywhere had ever produced anything so complex in such volume so quickly. Willow Run was not an isolated phenomenon. It was the most dramatic example of a transformation that swept through American industry. Boeing's Seattle plant employed 1,200 workers in 1940. By 1944, it employed 30,000. Consolidated expanded from its original San Diego facility to additional plants in Fort Worth, Texas, and New Orleans, Louisiana. Douglas Aircraft built factories in Oklahoma, Illinois, and California. North American Aviation established operations in Kansas City and Dallas. Grumman, Bell, Republic, Martin, Lockheed, Curtiss. Vought, every aircraft manufacturer in America, expanded at rates that seemed impossible until they became routine. But the expansion went beyond aircraft companies. Automobile plants converted to building engines, propellers, and components. General Motors produced 206,000 aircraft engines during the war, more than any specialized engine manufacturer. Chrysler built fuselage sections. Nash Kelvinator manufactured propellers. Goodyear produced components for B-29 Superfortresses. Even companies with no aviation experience entered production. The Wurlitzer Organ Company built wooden wing components for training aircraft. A corset manufacturer switched to producing parachute harnesses. A toy company began stamping aluminum instrument panels. The entire industrial economy reoriented itself toward a single purpose: building weapons, faster than the enemy could destroy them. The workforce transformed with the industry. In 1940, aircraft manufacturing employed 63,000 workers nationwide. By 1943, the number exceeded 2.1 million. Women flooded into factories that had previously barred them from anything beyond secretarial work. At Willow Run, women comprised 1/3 of the workforce at peak production. Rose Will Monroe, a Kentucky widow with 2 daughters, became one of the plant's most skilled riveters. She could drive 5 rivets per minute, 8 hours per day, 6 days per week. When war bond organizers needed a symbol for female war workers, they filmed Monroe at work. The resulting propaganda featured her in a headscarf and work coveralls, riveting gun in hand, building bombers for victory. Rosie the Riveter became an icon, but Rose Monroe was no abstraction. She was one of millions of women who learned skills in months that men traditionally required. Years to master. Material costs reflected the program scale. Each B-24 required 24,000 pounds of aluminum, 3,500 pounds of steel, 1,100 pounds of copper and brass, 600 pounds of lead, and 15 pounds of silver used in electrical contacts. Rubber consumption reached 850 pounds per aircraft for tires, fuel lines, gaskets, and vibration dampeners. Glass for windscreens, turret windows, and instruments consumed 500 pounds per bomber. Every B-24 needed 18,000 rivets, 500 bolts, 2,000 screws, and countless washers, nuts, cotter pins, and fasteners. Electrical wiring stretched 6.5 miles through each aircraft, connecting radios, instruments, autopilot systems, gun turret controls, landing gear motors, and fuel transfer pumps. The logistics were staggering. Building 300,000 aircraft required 12 billion pounds of aluminum, most of which had to be refined from bauxite ore that did not exist in commercial quantities before 1940. It required 2 billion pounds of rubber for tires, fuel lines, and gaskets at a time when Japan controlled 90% of the world's natural rubber supply, forcing development of synthetic rubber from scratch. It required 140 million pounds of high-octane aviation fuel monthly, which had to be refined from petroleum using processes that were still experimental in 1939. It required optical glass for bomb sights, radios for communications, instruments for navigation, oxygen systems for high-altitude flight, and specialized machine tools capable of working aluminum to tolerances measured in 10,000ths of an inch. Every component had to be manufactured, tested, inventoried, shipped, and integrated into final aircraft assembly. The supply chain involved tens of thousands of companies, millions of workers, billions of individual parts moving through a system that had not existed 5 years earlier. President Roosevelt's December 29, 1940, fireside chat delivered 8 months before Pearl Harbor laid out the rationale that would drive this industrial transformation. Speaking directly to the American people via radio, Roosevelt declared, "We must be the great arsenal of democracy. For us, this is an emergency as serious as war itself. We must apply ourselves to our task with the same resolution, the same sense of urgency, the same spirit of patriotism and sacrifice as we would show were we at war." The phrase arsenal of democracy captured the essence of America's role in the conflict. Britain and the Soviet Union would provide the soldiers. America would provide the weapons. The division of labor made strategic sense. The United States possessed industrial capacity that exceeded any other nation, but maintained a relatively small peacetime military. Converting that industrial might into weapons would achieve more than simply expanding the armed forces. Every tank built in Detroit was a tank that British or Soviet factories did not have to build, freeing their resources for other purposes. Every bomber produced at Willow Run was 10 fewer fighters than German factories could build, because aluminum allocated to defense could not be used for offense. In Germany, Hermann Göring watched American production figures with growing alarm. In 1940, he had laughed at 50,000 aircraft per year. By 1942, American factories produced 47,836 military aircraft. In 1943, production reached 85,898. In 1944, it peaked at 96,318. The numbers exceeded Göring's worst nightmares. Germany's entire aircraft production from 1939 to 1945 totaled 119,371 planes. America built that many in 15 months. The Luftwaffe could not replace losses. Every Messerschmitt Bf 109 shot down was one less fighter defending German cities. Every Focke-Wulf Fw 190 destroyed could not be easily replaced. German production peaked in 1944 at approximately 40,000 aircraft, a remarkable achievement for a nation under strategic bombing. But America produced more aircraft in 6 months than Germany managed in a full year. The impact revealed itself in every theater of war. The air war over Germany in 1943 demonstrated what insufficient production meant in combat terms. Operation Point Blank, the code name for the combined bomber offensive against German industry, targeted aircraft factories, ball bearing plants, synthetic fuel refineries, and transportation networks. The strategy made sense on paper. Destroy Germany's ability to produce weapons and victory becomes inevitable. But executing the strategy required bombers to penetrate hundreds of miles into hostile airspace defended by fighters and anti-aircraft guns. The 8th Air Force launched its first major raids in summer 1943. The results were catastrophic. The August 17, 1943, mission to Schweinfurt and Regensburg sent 376 B-17 flying fortresses deep into Germany to strike ball-bearing factories and aircraft plants. The bombers flew without fighter escort because no Allied fighter possessed the range to accompany them to target and return. German fighters intercepted the formations over the Dutch coast and attacked continuously for hours. The bombers relied on defensive firepower. Each B-17 carried 10.50 caliber machine guns in nose, tail, dorsal, ventral, and waist positions. In theory, tight formations created overlapping fields of fire that made attacking them suicidal. In practice, German pilots developed tactics that exploited gaps in coverage, attacking from head-on at closing speeds exceeding 500 miles per hour, breaking off before defensive gunners could track them. 60 B-17s went down. 55 more were damaged beyond repair. 600 crewmen were killed or captured. The losses represented 30% of the attacking force. The 8th Air Force struck Schweinfurt again on October 14, 1943, sending 291 bombers against the ball-bearing plants. German defenses were ready. Luftwaffe fighters concentrated their forces, attacking in waves of 50 to 100 aircraft each. The bombers fought back desperately, gunners firing until barrels glowed red, formations tightening to maximize defensive fire. It was not enough. 60 bombers went down over the target. 5 more crashed attempting to reach England. 17 landed at emergency airfields, too damaged to fly further. Losses again approached 30%. These rates were unsustainable. Bomber crews flew 25 mission tours. Losing 30% per mission meant average life expectancy was 3 missions. The mathematics of survival were impossible, yet the raids continued. That was the lesson Göring failed to comprehend. The 8th Air Force could sustain losses that would cripple any other air force because American factories replaced every bomber lost. The 120 B-17s shot down in 2 missions represented approximately 1 week's production at Boeing's Seattle plant alone. Consolidated, Douglas, and Lockheed Vega built additional B-17s under license. Replacement crews trained at bases across the United States, learning navigation, bombing, formation flying, and gunnery before deploying to England. The pipeline never stopped. German defenders could kill hundreds of American airmen, destroy dozens of bombers, and still face larger formations the next week. In the Pacific, Japanese forces that had conquered the Philippines, Malaya, and the Dutch East Indies with aerial superiority found themselves outnumbered by mid-1943. American carrier task forces launched airstrikes with hundreds of aircraft. Island airfields supported fighter sweeps that overwhelmed Japanese bases. The Battle of the Philippine Sea in June 1944 became known as the Great Marianas Turkey Shoot when American fighters destroyed 600 Japanese aircraft in a single day. Japan could not replace such losses. America barely noticed the attrition. In Europe, the strategic bombing campaign against Germany demonstrated what unlimited industrial capacity meant in military terms. In 1942, the 8th Air Force struggled to put 50 bombers over Germany in a single raid. By 1944, 1,000 bomber formations struck German cities daily. Each raid lost dozens of aircraft to fighters in flak. It did not matter. Replacement aircraft arrived from American factories faster than combat could destroy them. The 15th Air Force operated from Italian bases, adding another 1,000 bomber capability. Our AF Bomber Command struck at night with its own massive formations. Germany faced 3 separate air armadas, each capable of devastating attacks, none of which could be defeated because losses were replaced overnight. The B-24 Liberator, the aircraft that Göring had dismissed as unprovable fantasy, became the most produced American military aircraft in history. Total production reached 18,482 bombers. Willow Run alone built 8,685 of them. The B-17 Flying Fortress, produced by Boeing, Douglas, and Lockheed Vega, totaled 12,731 aircraft. The P-51 Mustang fighter, which gave American bombers the long-range escort capability that broke the Luftwaffe's back, reached production of 15,586 aircraft. These were not prototypes or experimental designs. They were operational combat aircraft, each one flown to war, many never returning. All of them replaced by fresh aircraft rolling off assembly lines that never stopped producing. The human cost of this production miracle receives less attention than the statistics, but was no less significant. Workers died in industrial accidents. In 1943, Factory fatalities in aircraft manufacturing exceeded 200 monthly nationwide. Explosions in paint shops killed dozens when volatile solvents ignited. Workers fell from bomber wings during assembly. Heavy components crushed people when cranes failed. The pace was relentless. Shifts ran 10 to 12 hours, 6 days per week. Fatigue caused errors. Errors caused injuries. Injuries were accepted as the price of production. No one protested. Everyone understood that delays meant soldiers died. Better to risk factory workers than fail the men in combat. By late 1944, American aircraft production faced a different problem: overproduction. Factories built aircraft faster than the military could absorb them. Storage fields filled with new bombers awaiting assignment. Fighter aircraft sat in packing lots with engines pickled for preservation. Production schedules were scaled back, not because capacity failed, but because output exceeded demand. It was a problem no other nation faced. Germany struggled to maintain production under Allied bombing. Japan's factories burned in firebombing raids. Britain rationed aluminum and copper. The Soviet Union relocated entire industries to the Ural Mountains to escape German advance. Only America worried about building too many weapons. The turning point came in the skies over Germany in early 1944. The Luftwaffe mounted desperate defenses against American daylight bombing raids. German fighters attacked in waves, accepting catastrophic losses to stop the bombers. The strategy worked initially. Raids on Schweinfurt and Regensburg in August and October 1943 cost the 8th Air Force over 100 bombers in each attack, losses that would have crippled any other air force. American commanders ordered follow-up raids within weeks, replacing losses from the endless flow of aircraft arriving from American factories. The Luftwaffe could not sustain such attrition. German fighter production, despite Albert Speer's armaments miracle, could not match losses. Experienced pilots died and could not be replaced. Training programs shortened to push new pilots into combat faster, resulting in even higher casualties. By June 1944, the Luftwaffe had effectively lost control of German airspace, not because German aircraft were inferior, but because there were too few of them. The D-Day invasion in June 1944 demonstrated total Allied air superiority. On the morning of June 6th, the Allied Expeditionary Force flew 14,000 sorties supporting the landing. The Luftwaffe managed 2 sorties, 2 aircraft over Normandy, while thousands of Allied planes controlled the sky. German commanders requested air support that did not exist. Panzer divisions moved only at night to avoid fighter-bomber attacks. Supply convoys burned on roads. Reinforcements arrived decimated by strafing runs. The mighty Wehrmacht, which had conquered Europe with combined arms warfare that depended on Luftwaffe support, found itself fighting blind and immobile. The absence of German air power was more decisive than the presence of Allied armor. In the Pacific, the story repeated with different details. Japan had begun the war with technological advantages in certain aircraft types. The Mitsubishi A6M0 possessed range and maneuverability that exceeded any Allied fighter in 1941. Japanese pilots had combat experience from years of fighting in China. The surprise attack on Pearl Harbor demonstrated operational proficiency that shocked American military planners. But Japan's industrial capacity could not sustain the war of attrition that followed. In 1941, Japan produced 5,088 military aircraft. Peak production in 1944 reached 28,180 aircraft, an impressive increase. But America produced 96,318 aircraft that same year, more than triple Japanese output. The mathematics of survival were impossible. Every carrier lost at Midway was irreplaceable. Every pilot killed in the Solomons left a gap that could not be filled. By 1945, Japan resorted to kamikaze attacks not because of cultural preference for suicide, but because conventional attacks were unsustainable, given aircraft losses and pilot inexperience. The B-29 Superfortress represented the ultimate expression of American industrial capacity applied to warfare. Designed in 1940, the B-29 was the most complex aircraft ever built. A pressurized strategic bomber capable of carrying 8 tons of bombs, 3,200 miles at altitudes exceeding 30,000 feet. Development costs exceeded $1 billion, more than the Manhattan Project's initial budget. The aircraft featured innovations that pushed engineering boundaries: remote-controlled gun turrets, analog computers for bombing calculations, reversible pitch propellers, and pressurized crew compartments that allowed operations at altitudes where Japanese fighters could not reach. Production began in 1943. By 1945, America had built 3,970 B-29s. The program succeeded not because of technological superiority alone, but because American industry could afford to develop such expensive weapons while simultaneously producing tens of thousands of conventional aircraft. The firebombing of Tokyo in March 1945 employed 279 B-29s, dropping 1,665 tons of incendiary bombs on the Japanese capital. The resulting firestorm killed over 100,000 people and burned 16 square miles of the city to ash. The raid was not unique. American B-29s struck Japanese cities throughout the spring and summer of 1945, burning Osaka, Kobe, Nagoya, Yokohama, and dozens of smaller cities. Japan could not defend against the attacks. Fighter aircraft that could reach B-29 altitudes did not exist in sufficient numbers. Anti-aircraft guns lacked the range. The raids continued not because they were strategically necessary, but because American industrial capacity made them possible. Factories built aircraft faster than combat could destroy them. Crews flew missions until they completed their tours. Then new crews took their places. The bombers kept coming because the factories kept producing. In his cell at Nuremberg in 1946, Hermann Göring faced Allied prosecutors. They asked him about his decision-making during the war. The Reichsmarshal, who had once sneered at American production capacity, admitted the truth he had learned too late. American aircraft production, he testified, exceeded my worst fears. We could never match it. The numbers were beyond anything we had considered possible. He paused, looking older than his 53 years, and added, "I underestimated American industry. It was my greatest mistake." The numbers support his admission. Total American aircraft production from 1940 to 1945 reached 324,750 military aircraft. Germany produced 119,371. Japan manufactured 76,320. Britain built 131,549. The Soviet Union produced 157,261. America alone built more military aircraft than Germany, Japan, and Britain combined. The production surge began in 1940, when Roosevelt announced his seemingly impossible goal of 50,000 aircraft per year, and peaked in 1944, when American factories produced 96,318 aircraft in 12 months, not the 50,000 Göring had mocked, but nearly double that figure. The achievement redefined what industrial societies could accomplish under total mobilization. But the achievement came with costs that statistics cannot capture. The 2.1 million workers who built these aircraft included hundreds of thousands who had never held factory jobs before 1941. Women who had been homemakers learned to rivet aluminum. Men who had farmed learned to machine steel. Families relocated across the country to find work in defense plants. Children grew up in hastily constructed housing developments near factory complexes. Communities transformed overnight from agricultural towns to industrial centers. Willow Run's workforce came from every state in the Union, speaking different languages, bringing different customs, united only by the urgency of production. They worked in factories that were freezing in winter and sweltering in summer. They breathed aluminum dust and solvent fumes. They lost fingers to stamping presses and eyes to metal splinters. They did it for the paycheck, yes, but also because everyone understood that the war could be lost if production failed. The economic transformation was equally profound. Government spending on war production exceeded $100 billion between 1940 and 1945, an almost incomprehensible figure at a time when the entire federal budget had been $9 million in 1939. Factories that had been empty during the Depression operated at capacity. Unemployment disappeared. Wages rose. Women's participation in the workforce increased by more than 6 million. The South industrialized as defense plants located in Alabama, Georgia, and Texas. The West Coast grew explosively as aircraft factories concentrated in California and Washington. The economic geography of America shifted permanently. War production created the industrial infrastructure that powered American prosperity for the next 4 decades. The military implications extended beyond simple numerical superiority. American aircraft were not just numerous. They were increasingly sophisticated. The P-51 Mustang represented the culmination of fighter design evolution, combining American airframe engineering with British Rolls-Royce Merlin engines to create a fighter with range, speed, and maneuverability that exceeded anything Germany could deploy in significant numbers. The B-29 Superfortress incorporated technologies that would define post-war aviation, pressurization, radar bombing, remote weapon systems, and long-range strategic capability. These aircraft succeeded not because individual examples were superior, but because industrial capacity ensured that superiority was deployed in overwhelming numbers. A single P-51 was competitive with a German fighter. 500 P-51s escorting bombers to Berlin made German fighters irrelevant. The strategic flexibility the production capacity provided proved equally important. When the 8th Air Force suffered catastrophic losses in 1943, the response was not to abandon daylight bombing, but to produce more bombers and develop long-range escort fighters. When kamikaze attacks in the Pacific damaged carriers, the response was to build more carriers and deploy additional fighters. When submarines threatened Atlantic convoys, the response was to produce more patrol aircraft and escort vessels. The United States could afford to make mistakes because industrial capacity allowed multiple approaches to be attempted simultaneously. Germany and Japan had to choose carefully because every resource committed to one strategy was unavailable for others. America could pursue every strategy at once. The German response to American production demonstrated the futility of competing on industrial terms. Albert Speer, appointed Minister of Armaments and War Production in February 1942, implemented reforms that tripled German aircraft production between 1942 and 1944. His achievement was remarkable. Accomplished under strategic bombing that destroyed factories, killed workers, and disrupted supply chains. German production peaked at 40,000 aircraft in 1944, a figure that would have been decisive in 1940. But by 1944, American production exceeded 96,000 aircraft. For every German fighter that rolled off production lines, American factories built 2. The disparity was insurmountable. Speer's miracle was real, but it arrived too late against an opponent whose industrial base was untouchable and whose Production capacity exceeded Germany's by factors of magnitude. The Japanese situation was worse. Japan's industrial capacity never approached Germany's. Total Japanese war production of all military aircraft from 1941 to 1945 reached 76,320 planes. American factories produced that many aircraft in 9 months. Japan could not compete, could not catch up, could not survive. The decision to attack Pearl Harbor guaranteed defeat not because the attack failed, but because it initiated a war of industrial attrition that Japan could never win. Admiral Isoroku Yamamoto, who planned the Pearl Harbor attack, understood this. He famously warned that Japan could run wild for 6 months to a year, but could not win a prolonged war. He was wrong only about the timeline. Japan ran wild for 18 months before American industrial production turned the tide. Irreversibly, the legacy of American war production extended far beyond World War II. The factories built to produce bombers converted to building commercial aircraft after 1945, creating the foundation for American dominance in civil aviation that persisted into the 21st century. Boeing, Douglas, Lockheed, and McDonnell all became major commercial manufacturers using technology and production techniques developed during the war. The workforce that learned precision manufacturing in aircraft plants transferred those skills to automobiles, appliances, and consumer electronics. The management techniques developed to coordinate production across hundreds of suppliers became standard practice in American industry. The technological innovations, aluminum alloys, precision instrumentation, electronic systems, advanced aerodynamics, found civilian applications in products, ranging from pressure cookers to medical equipment. The social legacy was equally significant. Women who entered factories during the war discovered capabilities that traditional society had denied them. Not all remained in industrial work after 1945. But those who did established precedents that could not be undone. Equal pay for equal work, pioneered at Willow Run and other defense plants, became a rallying point for post-war labor movements. African Americans who migrated north to work in war industries found opportunities that did not exist in the segregated South, accelerating demographic shifts that transformed American cities. The shared experience of war production created a sense of national unity that transcended regional and class divisions. For 4 years, everyone understood that individual success depended on collective effort. The assembly line worker riveting bomber wings was as essential as the pilot flying combat missions. But perhaps the most important legacy was the demonstration of what concentrated national effort could achieve. In 1940, producing 50,000 aircraft per year seemed impossible. 5 years later, America had produced more than 300,000 military aircraft. The transformation occurred not through magic or miracle, but through systematic application of engineering principles, organizational discipline, and focused resource allocation. Problems that appeared unsolvable were broken into components and solved sequentially. Bottlenecks were identified and eliminated. Expertise was shared across companies. Competition was subordinated to cooperation. The government coordinated private industry without nationalizing it, creating partnerships that leveraged corporate efficiency while directing production toward national priorities. This model influenced post-war American thinking about technological challenges. When the Soviet Union launched Sputnik in 1957, the American response was not despair, but mobilization. The space program that landed astronauts on the moon a decade later employed organizational principles, pioneered during wartime aircraft production. Clear objectives, massive resource allocation, coordination across multiple organizations, and acceptance of failure as part of the learning process. When the energy crisis of the 1970s demanded new technologies, policymakers looked to war production as proof that rapid industrial transformation was achievable. When the computer revolution required manufacturing capacity that did not exist, the model of coordinated production scaling provided guidance. The B-24 Liberators that rolled off Willow Run's assembly line in 1944 are mostly gone now. A few survive in museums, carefully preserved, their aluminum skins polished to mirror finishes that obscure the haste with which they were built. Visitors walk beneath their wings and marvel at their size, their complexity, their engineering. Few understand that the marvel is not the individual aircraft, but the system that produced them. At peak production, Willow Run completed one B-24 every 63 minutes. Think about that. A 4-engine bomber, weighing 32 tons empty, containing nearly 500,000 parts, assembled from raw materials to finished aircraft ready for combat in 24 hours. Not one example painstakingly crafted over months. One every hour, day and night, month after month, sustained for 2 years. That is the achievement. That is what Hermann Göring failed to understand when he laughed at Roosevelt's announcement. The Reichsmarschall understood warfare. He had flown combat missions, commanded squadrons, built an air force. He understood tactics, strategy, operational planning. What he did not understand was that modern warfare had transcended traditional military considerations. Victory no longer belonged to the nation with the best soldiers or the most advanced weapons. Victory belonged to the nation that could produce weapons faster than the enemy could destroy them. The assembly line was more decisive than the battlefield. The factory worker was as crucial as the combat pilot. Industrial capacity determined victory more than military courage. Göring, like many military leaders of his generation, never fully grasped this transformation. He believed in the superiority of German arms, the quality of German engineering, the skill of German pilots. All true, all irrelevant when confronting an opponent who could replace every loss overnight and field ever larger forces month after month after. Month. American industry did not defeat Nazi Germany and Imperial Japan alone. Soviet armies destroyed the Wehrmacht in the East. British resilience prevented invasion in 1940. Resistance movements tied down occupation forces across Europe and Asia. Cryptographers broke enemy codes. Scientists developed radar, sonar, and nuclear weapons. But none of these factors could have succeeded without the industrial foundation that supported them. The Soviet Union survived because American trucks carried Russian soldiers. American locomotives moved Russian supplies. And American food fed Russian armies, while Soviet industry focused on tanks and artillery. Britain endured because American aircraft replaced British losses. American ships carried British supplies. And American production guaranteed that Germany could never achieve victory through attrition. The atomic bombs that ended the war in the Pacific were delivered by B-29 superfortresses, the final product of the industrial mobilization that began with Roosevelt's announcement in May 1940, 70 years after Willow Run produced its last B-24. The plant still stands, though production ceased in 1945, and most of the facility has been demolished. Preservationists saved a portion of the building, converting it into a museum. Visitors walk the same floors where workers assembled bombers around the clock. They see photographs of the assembly line in operation, the overhead conveyor carrying fuselages, the workers in coveralls and headscarves performing their repetitive tasks. They read statistics about production rates and worker numbers. They examine tools and components. Most leave impressed by American industrial might. Few leave understanding the deeper lesson, that societies are capable of achieving goals that seem impossible if they commit resources, coordinate efforts, and refuse to accept failure. That lesson remains relevant. Climate change demands technological transformation on scales comparable to wartime mobilization. Renewable energy requires building production capacity that currently does not exist. Energy storage needs manufacturing systems not yet developed. Transportation electrification requires supply chains not yet established. These challenges seem overwhelming, impossible given current capabilities. So did building 50,000 aircraft per year in 1940. The difference between impossible and inevitable is commitment, coordination, and time. Not much time. Willow Run went from farmland to producing bombers every hour in 30 months. The entire American aviation industry went from producing 3,000 aircraft annually to producing 96,000 in 4 years. These transformations occurred with 1940s technology and communication systems. Modern capabilities are incomparably more powerful. What blocks similar achievements today is not capability, but will. The political consensus that drove wartime production does not exist for peacetime challenges. The sense of urgency that justified massive resource allocation has no equivalent in contemporary policy. The willingness to accept disruption, dislocation, and rapid change lacks modern constituencies. People want transformation without discomfort, progress without cost, achievement without sacrifice. Wartime production succeeded precisely because society accepted costs. Workers relocated across the country. Companies abandoned profitable product lines. Consumers tolerated shortages and rationing. Everyone understood that inconvenience was temporary and necessary. Modern society demands convenience first and resists policies that impose short-term costs for long-term benefits. But the capability remains. The knowledge of how to mobilize industry, coordinate production, and scale manufacturing is not lost. The organizational principles that turned automobile factories into bomber plants can turn refineries into renewable energy facilities, can convert combustion engine plants into electric motor production, can transform supply chains from fossil fuel-based to sustainable alternatives. The workforce that learned to rivet aluminum in 1942 proved that people can acquire new skills rapidly when motivated. The modern workforce can do the same. The question is not whether transformation is possible. History proves it is. The question is whether modern society will commit to transformation with the same intensity that 1940s America committed to war. Production. Hermann Göring's laughter echoes across decades as a warning about underestimating American capacity. But it also serves as a reminder that capacity without commitment is meaningless. America in 1939 possessed all the resources it would need to build 300,000 aircraft. It had aluminum deposits, industrial infrastructure, skilled workers, and technological knowledge. What it lacked was the decision to commit those resources toward a specific goal. Roosevelt's announcement in May 1940 was not a prediction of inevitable capability. It was a choice to mobilize, a decision that specific objectives justified specific sacrifices. That choice and the organizational effort that followed transformed capacity into reality. The same choice faces every generation confronting challenges that exceed apparent capabilities. The same transformation is available to those willing to make it. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world. The war's end brought questions about what to do with the vast industrial apparatus that had been created. In August 1945, VJ Day celebrations filled American streets with jubilant crowds. But in factories across the nation, managers faced an immediate crisis. Willow Run had employment contracts for 42,000 workers, building bombers at a rate of 1 per hour. Those contracts would terminate within weeks. Boeing's Seattle plant had transformed from a small operation, employing 1,200 workers into a massive complex with 30,000 employees. Douglas aircraft facilities in California, Oklahoma, and Illinois employed tens of thousands more. The sudden peace meant these workers would lose their jobs unless the factories could transition to peacetime production quickly. Some companies planned ahead. Boeing and Douglas began designing commercial aircraft during the war, anticipating post-war demand for airliners to replace the obsolete pre-war designs. Lockheed followed similar strategies. But the transition was neither smooth nor guaranteed. Willow Run ceased B-24 production on June 28, 1945, when the last bomber rolled off the assembly line. Workers who had spent years building instruments of war suddenly found themselves unemployed. Ford attempted to convert the facility to automobile production, but the plant's design, optimized for aircraft assembly, proved unsuitable for cars. The overhead conveyor systems that had moved bomber fuselages could not accommodate automobile bodies. The precision machine tools that shaped aircraft aluminum were incompatible with heavier automotive steel. Ford eventually sold that facility. Various companies occupied portions of the massive building over subsequent decades, but none replicated the focused intensity that had characterized wartime operations. Today, most of Willow Run has been demolished. A small section survives as a museum, a monument to what American industry achieved when necessity demanded the impossible. The workers who had built the arsenal of democracy dispersed across the country, carrying skills that transformed post-war manufacturing. Women who had learned precision riveting at Willow Run found employment in automotive plants, appliance factories, and electronics assembly operations. Men who had machined aircraft engine components applied that expertise to peacetime products requiring similar tolerances. The quality control methodologies developed to ensure aircraft safety standards migrated to industries that had previously accepted much looser specifications. Consumer products improved as a direct result of wartime manufacturing discipline. The post-war American economy, characterized by abundance of reliable consumer goods, was built on foundations laid in aircraft factories between 1940 and 1945. The geopolitical consequences extended beyond immediate military victory. American industrial capacity had won the war, but maintaining that capacity shaped the post-war world order. The Marshall Plan, which rebuilt Western Europe between 1948 and 1952, was predicated on American industrial surplus. Factories that had built bombers now built tractors, trucks, and construction equipment for European reconstruction. The same organizational systems that coordinated wartime production were repurposed to manage foreign aid logistics. Steel mills that had supplied armor plate for tanks provided structural steel for rebuilding cities. The expertise gained coordinating supply chains across thousands of companies facilitated international commerce at scales previously impossible. American economic dominance in the 3 decades following the war was not accidental. It was the direct consequence of industrial mobilization that had created capabilities unmatched by any other nation. The Cold War amplified rather than diminished these advantages. When the Soviet Union emerged as a rival superpower, the United States possessed industrial infrastructure specifically designed for military production. Converting aircraft factories from bomber production to jet fighter production required modifications rather than complete reconstruction. The supply chains that had delivered components for B-24S adapted to deliver components for F-86 Sabres. The workforce that had learned precision manufacturing during World War II transferred those skills to building guided missiles, electronic systems, and eventually spacecraft. The Apollo program that landed Americans on the moon employed organizational techniques pioneered at Willow Run, breaking complex systems into manageable subassemblies, standardizing components for interchangeability, coordinating thousands of suppliers, and maintaining quality control through statistical sampling rather than individual inspection. The assembly line principles. the Chaucer applied to bombers in 1942 were recognizable in NASA's spacecraft. Production 30 years later, military aviation itself, transformed as a consequence of wartime production lessons. Pre-war aircraft design emphasized individual performance characteristics. Each new model sought marginal improvements in speed, range, or firepower. Post-war design increasingly emphasized production feasibility. An aircraft that was 10% faster but 20% more difficult to manufacture was inferior to one that prioritized ease of production. This philosophy reached its apex in aircraft like the F-16 Fighting Falcon, designed in the 1970s with manufacturing efficiency as a primary objective. The F-16 incorporated modular components that could be produced by multiple suppliers and assembled rapidly. Over 4,600 F-16s have been built since 1976, making it one of the most successful fighter aircraft in history. That success reflects lessons learned when Ford attempted to mass-produce the B-24. Design for manufacturability became a fundamental principle in aerospace engineering, and it originated in the failures and eventual successes of Willow Run. The economic theories that guided post-war American policy also reflected wartime experience. Keynesian economics, which advocated government intervention to manage economic cycles, gained credibility from war production success. If government coordination could multiply aircraft production 20-fold in 4 years, similar approaches might solve peacetime economic problems. The interstate highway system, authorized in 1956, employed organizational models developed during war mobilization, coordinating construction across thousands of contractors, standardizing specifications to ensure interoperability, and managing budgets that exceeded any previous peacetime expenditure, all borrowed from techniques refined building the arsenal of democracy. Whether these applications were appropriate for peacetime challenges remains debated, but the influence is undeniable. World War II production taught Americans that large-scale government coordination of private industry could achieve results impossible through purely market mechanisms. The human legacy is more difficult to quantify, but perhaps more significant. An entire generation learned that ordinary people could accomplish extraordinary things when necessity demanded it. Rose Monroe, the Kentucky widow who became Rosie the Riveter, returned to civilian life after the war and eventually opened her own construction business. She had learned at Willow Run that she possessed capabilities society had never acknowledged. Thousands of women had similar experiences. Not all translated wartime skills into post-war careers, but many did. The women's liberation movement of the 1960s and 1970s drew strength from memories of what women had achieved when opportunity was provided. The arguments for gender equality in employment became harder to dismiss when an older generation remembered assembling bombers that defeated the Axis powers. African Americans who had migrated north to work in defense industries experienced similar transformations. The experience of earning good wages in integrated factories, living in communities where racial segregation was less absolute than in the South, and being treated as essential workers rather than second-class citizens created expectations that could not be suppressed. The civil rights movement drew energy from these experiences. When Martin Luther King Jr. spoke of economic justice, his audience included people who remembered earning equal pay for equal work at Willow Run. The social changes that transformed America in the decades following the war were not caused solely by wartime production, but they were influenced by it. Millions of Americans had proof that alternative social arrangements were possible because they had lived them in war. Factories. The technological acceleration that characterized the late 20th century also traces roots to wartime production. The urgency of war forced rapid development cycles that peacetime industries had never attempted. Aircraft that took 5 years to develop before 1940 were designed, tested, and put into production in 18 months during the war. The B-29 Superfortress went from initial concept to operational deployment in less than 4 years, despite being the most complex aircraft ever built. That pace became the expectation rather than the exception. Post-war aerospace companies competed on development speed as much as technical performance. The willingness to accept technical risk, to commit resources to unproven concepts, to test systems under real-world conditions rather than waiting for perfect laboratory validation. All these approaches originated in wartime necessity and persisted in peacetime. Competition. The relationship between government and industry fundamentally changed. Before 1940, American industry was deeply skeptical of government intervention. The Depression had been marked by conflict between business leaders and Roosevelt's administration over regulation and labor policy. War production forced cooperation. William Knudsen exemplified this shift. As president of General Motors, he had opposed New Deal policies. As director of war production, he worked seamlessly with government bureaucrats, military officers, and labor unions to achieve common objectives. That cooperation persisted after the war in forms like the President's Council of Economic Advisors, the National Science Foundation, and numerous public-private partnerships. The modern American economy, characterized by extensive interaction between government policy and private enterprise, reflects relationships forged when building the arsenal of democracy. Hermann Göring lived long enough to see the full extent of his miscalculation, but not long enough to witness its lasting consequences. On October 15, 1946, hours before his scheduled execution at Nuremberg, he committed suicide using a cyanide capsule that had been smuggled into his cell. His final statement to the tribunal had acknowledged defeat but claimed that German forces had fought honorably. He never fully accepted that the war had been lost, not on battlefields, but in factories, not through military failure, but through industrial insufficiency. His laughter in 1940, when he dismissed American production goals as propaganda, became in retrospect a symbol of the broader Axis failure to comprehend the nature of modern war. Military excellence mattered less than industrial capacity. Tactical brilliance meant nothing without logistical support. Individual heroism could not overcome systematic material advantage. The lesson seems obvious in retrospect, but was not apparent at the time. In 1940, Germany possessed Europe's most advanced military, battle-tested troops, proven equipment, and recent victories that demonstrated operational superiority. The Luftwaffe had defeated the Polish Air Force in days and the French Air Force in weeks. German pilots were experienced, German aircraft were competitive, and German tactics were sophisticated. American military aviation, by comparison, was theoretical. U.S. Army Air Corps pilots trained in obsolescent aircraft. American bombers were untested in combat. American fighters were judged inferior to European designs. The notion that American industry would prove decisive seemed unlikely based on 1940 evidence. Göring's laughter was not unreasonable. It was wrong, but not absurdly so. What Göring failed to anticipate was the scalability of American industrial systems. He understood that America possessed vast resources, but assumed that converting resources into weapons required time Germany would not permit. The calculation was logical. If America needed 5 years to mobilize fully, and Germany could win the war in Europe within 2 years, American resources were irrelevant. Britain would surrender or be invaded. The Soviet Union would be defeated or would sue for peace. Germany would control a continental empire with resources rivaling America's. The war would end before American industry could affect outcomes. This calculation failed because it underestimated the speed of American mobilization. Göring assumed American industry would convert to war production using traditional methods. He could not conceive that automobiles would be built in factories, using assembly techniques that consolidated aircraft's craftsmen would consider impossible. The paradigm shift that Willow Run represented was outside his framework. He understood aircraft production as it existed in 1940. He could not imagine aircraft production as it would exist in 1944. The final irony is that Göring's expertise in aviation, which made him confident in dismissing American production goals, was precisely what blinded him to the possibility of success. He knew too much about how aircraft were built to believe they could be built differently. Charles Sorensen, who understood nothing about aircraft but everything about manufacturing, saw possibilities that aviation experts missed. This pattern repeats throughout industrial history. Paradigm shifts come from outsiders who lack the expertise that insiders use to explain why innovation is impossible. Ford's application of assembly line techniques to aircraft construction succeeded because Ford did not know enough about aviation to understand why it should fail. The modern observer, looking back across 8 decades, sees inevitability where contemporaries saw uncertainty. Of course, America would outproduce Germany. Of course, assembly lines would multiply aircraft output. Of course, women could rivet aluminum as well as men. Of course, Willow Run would succeed. But none of it was obvious at the time. Willow Run almost failed. Production goals almost proved unattainable. The entire enterprise could have collapsed into expensive futility. It succeeded because thousands of individuals refused to accept failure, learned from mistakes, adapted techniques, and persevered through setbacks that justified abandonment. History remembers the ultimate success, but forgets the provisional nature of that success while it was being achieved. That forgotten contingency carries lessons for contemporary challenges. Climate change, like fascism in 1940, threatens civilization. Technological transformation, like industrial mobilization then, offers potential solutions. The scale of required change seems impossible given current capabilities. Just as 50,000 aircraft per year seemed impossible in 1940, but impossibility is often a failure of imagination rather than a limitation of capability. What appears impossible becomes inevitable when societies commit resources, accept disruption, and refuse failure. The arsenal of democracy was not destiny. It was choice. Americans in 1940 chose to transform their economy, their society, and their relationship with government to build weapons. The transformation succeeded not because success was guaranteed, but because failure was unacceptable. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world.